Hello everyone, this is James Shore with another test-driven development video. I'm recording this on July 11th, 2012, and we're going to pick up where we left off in the last episode. What we were doing, that was yesterday evening when I recorded that, so what we were doing is working on getting linting working, and that's pretty much done. The main thing I wanted to do that I made a note of between episodes is I really need to bring in all the linting options. And the lint runner under the covers runs JS Hint, and JS Hint has a nice set of options. JS Hint, by the way, is based on Douglas Crockford's JS Lint. Again, see that lessons learned video for more details. But it's got a good set of options, and I like to start out being really strict about the options, just because it's easier to loosen up the strictness of your code than it is to make it more strict. So for example, if I say that bitwise operators are not allowed, and then later on discover a situation where I want to use bitwise operators, I can either select that on a case-by-case basis, or I can just enable it globally. On the other hand, if I allow bitwise operators and then later on realize that that's a bad idea, I have to go through all the code and take them all out. Now, bitwise operators are kind of a bad example for that, but my point being that I want to go through and be very strict about my initial lint requirements, just so that if I decide that something's worthwhile, I don't have to go through all the source code in the future and put it in. It's easier to relax than to make more strict. For the options, I'm going to go ahead and use the same options I used for auto commit. I went through the JS Hint options in detail when I came up with that list, and I went through each one and picked those. So I am just going to grab those again. Here's the options. Just going to grab all of these. And again, if for your own projects, you should pick your own options, but if you're interested in knowing what these are, you can go to the JS Hint website. They're really well documented. Okay, there we go. We've got a few spelling errors. Oh, a lot of spelling errors. Let's just go ahead and fix all these. I'm a little torn. So WebStorm has this spelling error, this spelling checker in it, and I'm a little torn on it. I like having spell checking when I'm doing content, but it does catch, when you're programming, you're using a lot of words that aren't in the dictionary, so it does tend to catch a lot of stuff that I otherwise, sorry about that. It tends to flag a lot of stuff that I otherwise wouldn't care about. But I hate seeing the little squigglies in my code. So, okay, so there we go. Everything's passing. Yeah, I think that's good. So we've got our static code analysis working, I think. Is there anything else we want to do here? No, I don't think so. I think actually what I do want to do is I want to extract this out into a method, and let's call this node lint options. And I could see in the future possibly putting this into some sort of config file. One thing that I think is really important is it's very easy. These automated builds tend to get pretty complicated. And it's very easy to, even if you're being really rigorous and good about the rest of your code, it's really easy to let the build just sort of turn into this morass, because anytime you're working on the build, you're typically trying to get something else done, and you just want to, get it in quickly and be done. And the problem with that is that the build is really crucial to your code deploying successfully. And if you don't keep the code quality on that high, it can be a real point of failure. I'm not always good about it, but in this series, I'm going to try to be really rigorous and dedicated to keeping the automated build of high quality as well as the rest of the code. We'll see how that goes. I mean, ideally, what I'd like to do is actually test drive the build script as well as everything else. I've never done that before. It's kind of a theory. That is why I extracted out this validate file list code earlier, before I started recording this series. But it'd be neat if we could actually test drive the tasks and so forth. I don't know how to do that. It's a neat idea, but I don't want to spend too much time on the video on camera doing that. So I'm going to hold off on that for later. All right. We've got everything working. Oh, no, we don't. Oh, yeah, that. Let's see. Lint is complaining about node lint options being defined after it's used. Now, this actually is not a problem. This works just fine because JavaScript hoists the function. That is, it moves the declaration to the top when it parses. I'm not exactly sure why lint complains about this. I think there's some edge cases where it's an issue. But I like having my code read in order from generic to most specific. I could try to turn that feature off, but yeah, I think I'm going to turn that off. It might bite me in the butt later, but I really like having the readability of general to specific. I'm going to go look at the JS hint options, do a little research off camera, and I will be back in a moment. Okay, I'm back. So I did a little research into it, and there's this late def option allows you to disable the check for things being used before they're declared. But the problem is that applies to both functions and variables. And that's really not a good thing because of the way variable hoisting works, it is fairly error prone for variables. I don't think it's so error prone for functions, although I could be wrong about that. So I left the late def option turned on, so it will catch me if I use a variable before it's declared. But by wrapping the whole thing in an immediately executed function, I was able to work around it. I actually am not really sure what's happening internally that makes this okay, but did not make it okay when it was declared at the global level. It's not really at the global level because it's Node, but yeah, so it's working now. So let's move on. I think we've spent enough time on this. So the static code analysis is working. All right. So next is continuous integration. So we've done all this work. Speaking of which, let's go ahead and commit this. What did we do? We set up strict lint options. So we've got all this working. Next thing I'd like to do is continuous integration. And continuous integration is a bit tricky. It's not what most people say it is. Most people think of continuous integration as a tool, but that's not actually what continuous integration is. Continuous integration is nothing more and nothing less than having everybody on a project integrate with everybody else's work every couple of hours. And that when that work is integrated, that it's known good. In other words, it's technically shippable, even if it's not marketable shippable. So in other words, it builds and it runs and it passes all its tests, assuming you have a good test suite. And there's a lot of tools out there to run the build and test for you, but those tools are not really doing the hard part of continuous integration. The hard part of continuous integration is checking in every couple of hours and making sure the build is good. And in fact, a lot of continuous integration tools mess that up because they don't force the build to be good. They just tell you when it's bad. And because it's being run automatically rather than a person sitting there and waiting for it, the builds tend to get really long and take a couple hours and then fail. Continuous integration done well, the build never fails, ever. And this is kind of a hobby horse of mine. If you look up my name in continuous integration, you'll find me ranting about this. But some people like continuous integration builds tools because it tells them when the build fails or gives them a graph about when the build fails. They're completely missing the point. If the build ever fails, you're doing it wrong. Doing it wrong. I'm reminded of the XKCD comic where somebody on the internet is wrong and I've got to stay up all night solving it. Yeah, so continuous integration is about having a known good build all the time. So that's what we need to do. We need to set this up so that we have a known good build checked into sort of a master repository. And in particular, I'd like to get this puppy working on Windows. Because I know there's viewers out there who are going to be trying to run it on Windows. So I'm going to set up a continuous integration machine that's running Windows. And I'm not exactly sure how to do that. I mean, I have VMware, so I'll run a virtual machine. But the details from there, well, I have never done that before. Tried to continuously integrate to a Windows VM from my Mac. We'll see how that goes. So what we need is I think, okay, so I'm using Git, right? So let me go ahead and pull up the Git visualizer. So here it is. And this is all the check-ins for Git, and here are the episode tags, and here's where GitHub is, and here's where we are. And now in traditional continuous integration, before Git came along, the way it worked is you just integrated whenever you checked in. Now, the nice thing about Git and other distributed versioning tools is that you can check in anytime you want. I could potentially check in without having a known good build. And in fact, that's the situation we're in. I've checked in without knowing this works on Windows, which I think is part of our definition, going to be part of our definition of what it means for the build to be known good. In traditional, Subversion style continuous integration, you check into Subversion, you run the build. If it doesn't pass, you roll it back, or you fix it right away, and you use some sort of token to signal to other people that the build is not known good for a moment. But you just check into Subversion, and then all check-ins in Subversion are assumed to be known good. Because we're checking in a lot more frequently than we're integrating, technically, I think what we want to do is set up an integration branch that is going to be just for the known good builds. Now, I am not a Git expert, so I'm not exactly sure how this is going to work, but that's what I'm thinking, is that we will set up some sort of branch in Git that will be for integrations. The master branch will continue to be just for the everyday work that we're doing. And then whenever we do a continuous integration, we'll merge the master branch to the integrated branch, and that will be known good. I'm going to do a little research and figure out how that works. We are just about out of time for this episode, so I'll do that between episodes, and we'll see how that goes. Thanks very much for watching, everybody. Next time, we'll get the continuous integration set up. Thanks again. I will see you next time.